So, tomorrow morning at 11 o'clock, in the CAO seminar, Yael Amitai from the Kinneret lab will be talking about climate change, stratification collapse, and extreme thermal events in Lake Kinneret. On Sunday at 8:30, there'll be at the Geological Survey, there'll be a colloquium in Hebrew, I understand, and it'll be based on, or focusing on geological risks and earthquakes, and that'll be all day, I think. And now I'd like to introduce our speaker, Yigal Erel, which I don't think he really needs much of an introduction from me. But I would like to, I mean, he's got so many things here at the university, so I don't really want to talk about it. But there is one thing I would like to mention, is the book in Hebrew that we published last year on environmental sciences. And that will be really the cornerstone for people studying environmental sciences in Israel for the next long while, I'm sure. And without further ado, I'd like to hand it over to Yigal. Thank you.
Thank you, Simon. Thank you very much. What I'm going to present to you is a combination of work that I've been doing in the last few years. And many of the people who are in this room and who are not in this room, who are in this building, have contributed significant fractions to this journey. And if you want to summarize in one sentence, the take-home message of the seminar is that climate is not everything. And the crisis that we're facing, actually climate is a major part of it, but there are other as important parts to the crisis. And in my talk, first of all, I will present a brief history of the environment movement and the way I see the environmental crisis. Then I will show you a few slides about the magnitude of environmental problems and challenges. I will touch upon additional aspects and show that a lot of them are interconnected to one another. Then I will elaborate on the roots of the environmental crisis. And I will finish with occurring and needed mitigation processes, and try to sum up with some optimistic view. So, the climate crisis that everybody is talking about, from my perspective, is part of a deeper and broader phenomenon, which I call it the environmental crisis, which includes, among other things, depletion of natural resources, species extinction, soil and habitat destruction, greenhouse gas emissions, pollution and depletion of water resources, and a contamination of air and water bodies and the oceans. And the prerequisite to deal with this is to recognize that these multiple hazards are a part of the problem, and we have to acknowledge that there are a lot of interconnections, and we cannot separate variables. We cannot deal with one and ignore the rest. And the fundamental change has to be a fundamental change in social, economic, and moral paradigms. And I will elaborate on this more later. And of course, technological developments are essential, but they should be based on deep understanding of physical, chemical, biological, geological processes operating on Earth and how humans are interfering with them. And if we don't do it, if we don't take the big picture and try to change our ways, then the current crisis will intensify, and more crises will follow, and the climate crisis is not the last one that we are going to face and to deal with. So a few milestones in the evolution of environmental research and awareness. Maybe the first step takes us back to the 19th century, beginning of the 20th century, when in several countries around the world, people basically declared or designated areas and declared them as national parks. By the way, it's very hot. Global warming. Then there was a major event in London in 1952 when a combination of stagnant air masses and cold weather, which caused people to heat up their houses, caused a major increase in the concentrations of soot and sulfate particles and SO2. And immediately following that, the death toll went up from about 200 people dying per day to close to 1,000 dying per day. And this trend of excess dying lasted for several weeks following the decline of the pollution. So this raised a lot of concern, and I don't know if you ever watched this. There was a movie about Churchill, and I think that in one of the scenes, when he was a prime minister, he was the prime minister of the UK when this happened, and he was rushed to the hospital, and he was shocked to see the number of people in the hospital. Anyway, in the 50s and 60s, we saw a few important developments. First of all, 1957-58 was declared by the UN as the geophysical year, and part of it was established a monitoring station in Mauna Loa in Hawaii, where Charles Keeling and his associates started measuring CO2. And this is the record of CO2 that we have been following since then. In 1962, Rachel Carson published her book, Silent Spring, which showed the impact of excess use of pesticides, among them DDT, organophosphates, and others, on animals, on birds, and on human beings. Then in 1969 was a paper published by a group of scientists from Japan and from the US, led by Claire Patterson, where they traced lead pollution in the remote parts of the world. They saw that even in Greenland, they can trace lead pollution going back in time 1,000 years ago. And also the fact that this lead pollution, which came from activities of humans, reached these remote places on Earth. So pollution is not a recent phenomenon, and it's not restricted to the local environment. These findings and publications led to more awareness of this issue of environmental crisis. And in 1970, there was what they called the first Earth Day, where thousands or tens of thousands of people from various towns and cities in the US went out to the streets and started demonstrating against the excess use of pollutants and the emission of lead and other toxic compounds to the environment. And then in 1972, a group of economists and scientists established the Club of Rome, which basically said that there should be limits to growth. That the economy cannot grow forever on a finite climate, on a finite, Earth. And we have to limit our consumption of resources. Then, in the 70s, Wally Broker led a bunch of scientists which showed that the oceans are also part of the problem. They all play a central role in determining the climate of the Earth, but they also record excess use of various toxic and rare compounds by humans. And then in 74, Molina and Roland published a seminal paper on the depletion of the ozone layer, and took about 10 years for satellites to detect what they predicted in the paper, that excess emission of CFC compounds will cause depletion of ozone in the stratospheric in the stratosphere above Antarctica. In the 70s and then in the 90s, people have come to recognize that these changes that we are causing are not unique in the sense that the biota in general is interplaying with the environment and affecting the environment, and it's not only a passive resident on Earth. And actually, this is the Gaia hypothesis of Lovelock and Margulis. And then they came up some attempts to create measures to basically estimate the extent of changes happening on Earth. And the first measure was what they call the ecological footprint concept, which was published in '92. And I will go back to this later on. And in '92, Al Gore was the vice president of Clinton, published his book, Earth in the Balance, which for the first time put the environmental issues at the central stage of the political arena. And of course, the global warming that we're concerned about today is not a recent phenomena. Even Arrhenius in 1896 published a paper that predicted the increase of the excess use of coal and release of CO2 to the atmosphere will cause global warming. So now I will show you a few slides to emphasize the magnitude of the problem. And we'll start with the cycle of carbon, the global cycle of carbon, which the main issue here is the excess emission of carbon to the atmosphere as CO2. And these units are basically units of gigaton of carbon, not CO2, of carbon. Close to 10 gigaton of carbon are emitted every year to the atmosphere by human activities, and mostly by energy production, almost 3/4 of it, and then by agriculture activities. And in order to deal with it, people are always referring to these two processes: the solution of CO2 in the oceans and the photosynthesis and respiration on continents, which basically transfer much more, 10 times more carbon than emission of humans, as possible solutions to the excess emission of CO2 to the atmosphere. And of course, this excess emission led to what we have observed in the last few years, the increase in temperature of the Earth. This is relative to the years 1850 to 1900, which is roughly here. And you see that in 2020 we are at the 1.4 and approaching the 1.5 centigrade. And in some places on Earth, this is even worse. For instance, in our cities. This is Tokyo, and these are stations around Tokyo. And you see the temperature in these towns, 15 stations, increased over the years from 1900 to 2010 by 1 degree. But in Tokyo itself, the temperature increased by additional 2 degrees because of urban impact. This is called the urban island, heat island. And it's basically because of the way we modified the urban environment. So this is one example of the magnitude of the problem. The other one is this one. And this is what you see here is a chart showing you the distribution of surface on the Earth. 2/3 of the surface of the Earth are covered by oceans, and about 30% by continents, about 150 million square kilometers. Out of this, about 100 million kilometers are habitable. And out of these 100 million kilometers, about 50%, close to 50 million square kilometers, are used up by agriculture. And out of these 50 million, 37 million, about 77% of them, are for livestock, for meat and dairy. Only 23% are consumed to grow crops. And this is in spite of the fact that meat and dairy only give us less than 20% of our calorie consumption per day and less than 40% of our protein consumption per day. So we spend huge amount of land on relatively minor contributor to our diet. And we'll get back to this towards the end of the talk. And another angle of the problem is the decline in nature, the impact of humans on living things. 25% of species are under some risk of extinction. And even more troubling is the fact that we have altered completely the distribution of species. The fact that there are some species, the domesticated ones, which make up 82% of the mass of species on Earth. This is a paper by et al., which showed that the biomass of mammals, domesticated mammals, compared to wild mammals on Earth, the ratio is 14:1. The weight of all the cows and pigs and whatever to elephants and lions and so forth is 14:1. So we altered completely the makeup of the living world. And when we talk about the possibility of facing another major extinction, we always compare the situation today to the big five, the 5 extinctions that happened over the history of the Earth. And we see that there are species that, in white, what you see are the confirmed extinctions, and in black, the endangered species. And you can see that some, for instance, the cicada, are 64% of the cicada species are under threat of extinction. And the situation of harm to nature is not uniformly distributed. Places like South America, Africa, have a trend of worsening where the number of species under good conditions is declining. North America, Europe, and North Asia, the situation is better. And finally, I will touch upon the record of pollution of humans. And I will go to the work of my mentor, Claire Patterson, who showed using content of lead in bones and teeth of humans that contemporary humans are 1,000 times more polluted than the natural levels of pre-metal people. So if this one dot represents 40 milligrams of lead in a body of 70 kilogram person, this is the situation of all of us today. And when we reach this stage, 4 times more dots than here, we're hospitalized with lead pollution. But this story, of course, is not unique to lead. Other metals, such as mercury, cadmium, we also are exposed to them at excess levels. And on top of it, there are all this family of what they call novel entities or novel pollutants, such as PFAS, nanoparticles, and many others, that the background levels are 0, and we are exposed to them on our daily life. And every week, I see in the literature, people find more and more evidence for their extent of harming our health. And to summarize this magnitude issue, following the ecological footprint concept that I presented previously, people came up with other generalizing measures, one of them being planetary boundaries, which basically try to give a generalized assessment of the environmental condition on Earth. And this is the most recent one from 2025. And basically it has 9 categories. Novel entities, the one that I just mentioned, like PFAS and others. Stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification, excess or flow of nitrogen and phosphorus, use of water, fresh water, and green water, water stored in plants, land system changes, biosphere integrity, and climate change. And whenever we are in the green zone, we are okay. But as soon as we step into the orange or the red zone, we are basically causing harm to the environment and to ourselves. And you see that out of these 9 boundaries, 7 were crossed. The most recent one being the ocean acidification process. And if we look at the longitudinal view of this, in 2009, out of the 7 boundaries defined then, only 3 were crossed. In 2015, 4 were crossed. And in 2023, out of the 9 boundaries that I showed you before, 6 were crossed. So the situation is getting worse. So this is the magnitude of the problem we are facing. And some additional aspects and interesting interconnections. For instance, let's go back to the carbon cycle, in this case, the emission of CO2 to the atmosphere by humans. And again, the units is different because we're talking now about CO2 and not about carbon. So we're talking about close to 40 gigaton of CO2 emitted by humans. And this show you, I took 3 snapshots, 2003, 13, and 23. in 2003, about 28 gigaton of CO2 were emitted. In 35, and in 23, 37. So the delta went down. 7.6 here versus 2.5 there over these two period of time. But if we look at the CO2 in the atmosphere and the concentration of CO2 measured by Keeling and others in Hawaii, you see that the delta in CO2 increase remained the same. So the response to this decline in emission of CO2 is not translated immediately to a slowdown of CO2 in the atmosphere. And worse than that, if we look at CO2 and compare it to the record of temperature, we see that during these 20 years, the major jump happened at the second decade, not at the first decade. So these connections are much more complicated and difficult to deal with. They are not linear, and there are many reasons for this behavior that I don't have time to go into that. More so, when we look at the current situation of CO2 in the atmosphere and compare it to a record that goes back 800,000 years, we see that we are in a very peculiar situation. We are off the chart. And even in the last two interglaciations, 400,000 years ago, not last two, but two of the last interglaciations, and the last one from 125,000 years ago, the levels of CO2 were much, much lower than today, although they were higher than during glacial periods. They were about 280 ppm versus more than 400 ppm today. Even though, in spite of this, people have good evidence that during these two periods, 125 and 400, a large chunk of Greenland and some parts of West Antarctica basically lost their ice, and as a result, sea level rose by several meters. And maybe the situation was even worse than that about 3.3 million years ago. And we indeed are detecting a change in sea level. And these are meters, these are millimeters, but we still see a continuous increase in sea level going up from 1900 to 2020 by roughly 20 centimeters. And we also see that human activities are impacting those. First of all, for instance, when was in the 70s and 80s, there was a major global dam project where stopped the flow of water in rivers and preventing them from reaching the ocean. So the increase in sea level rise was a little bit slower. So what I'm saying is that we are indeed facing here, and this is a major problem because roughly 70% of the population of people on Earth live in coastal regions, and all of them will have to move to Jerusalem. And lastly, the fact that these changes that we see here, including the sea level rise, are predicted to last for a long period of time. When people say that these are irreversible processes, they mean that they're irreversible processes as far as we're concerned over the time of interest in humanity. And so here you see, for example, one of the what they call the RCP 4.5 the most probable scenario for the next decades is that temperature will increase by 2 to 3 centigrade by 2100, but the impact of it on CO2 and on other processes on Earth will last for hundreds of thousands of years. Okay. One more, when do you have to?
Lots of time.
Okay. Another example of the magnitude of the problem is the extent of impact of air pollution on human lives. These are several estimates done by various groups of scientists, and they all estimate that between 7 to 9 million people per year die because of exposure to air pollution, mostly fine particulate matter, and to a lesser extent by ozone and nitrogen oxide. And the cause for death is not only respiratory disease, but stroke and heart problems. These are based on both toxicological studies that use lab animals and on the epidemiological studies, which of course have a lot of noise on them. But they still are very severe problem. For instance, in China, 17% of the deaths per year are attributed to air pollution, or at least until recently. The air pollution, or the level of air pollution in China is relatively declining recently because of all kinds of measures that they have taken. And finally, this also goes into connection with climate change. You see, what you see here is a study that we did here in Israel, measuring PM 2.5 and PM 10, which are two types of particulate matter in the atmosphere, where the PM 2.5 are the finer particles and are more prone to cause health problems. And the ratio of PM 2.5 to PM 10 is very sensitive to the air masses coming to us. Whether we have air masses coming from, let's say, Europe, Eastern Europe, we see a high level of PM 2.5. 50% of the PM 10 is PM 2.5. Whereas when we see dust coming from the Sahara, only a quarter of PM 10 is PM 2.5. And the interplay between the different synoptic systems, which determine where the air mass is coming from, is very sensitive to climate change. So changes in climate will enhance the problems of air pollution, or might enhance. And just, I think this week, there was a publication about a report published by the UN that Safri Rinat wrote about it in Haaretz. The extent of a water shortage and the effect that basically humans are dramatically impacting the hydrological cycle. Here you see the hydrological cycle, and the units are thousands of cubic kilometers, or thousands of cubic kilometers per year if it's a flow. For instance, in rivers, we are talking about 40,000 kilometers of water flowing every year to the ocean. Humans are consuming 4.5, 10% of what's flowing in all the rivers in the world is being consumed by humans. And this extensive use of water, of course, is not uniformly distributed, and because there are many countries many of them are in our region, which have a critical water stress, which of course creates some problems, also geopolitical problems, which I will show you in a second. It also caused an excessive use of groundwater to accommodate the needs and in order to make up for all the water that we need and consume. And this is what you see here is the cumulative use of groundwater, mostly from fossil groundwater, over pumping of groundwater, going all the way to about 22,000 cubic kilometers by the year 2010. And the situation is even worse today, although there are not any measurements yet. And as I said, it caused geopolitical tensions. For instance, this is the Renaissance dam that Ethiopia built on the Blue Nile, and Egypt threatened to bombard it and attack Ethiopia if they operate it without considering the needs of Egypt for water. So the water is a major problem. So let's now jump to the roots of things. The roots is us, too many of us. The fact the human population is going up continuously. And look, even if you draw this line back in time and go through the Second World War, First World War, you would not notice it. There's not even a small dent in this curve, or a small dent. There is a small dent, but you have to work hard to notice it. So, huh? So the good news about this is that the extra people added to Earth every year went down from 83 million people between 2017 and 2018 to 65 or 66 million between 21 to 22. So the added so there is a slowdown in the a number of people added to Earth. But this is only part of the problem. The second part is this one. And how so? If we look at these planetary boundaries and we divide them according to wealth, and we look at different deciles, we see that in most cases the people who earn the most, the top 10%, or if you want the top 20%, the 1.6 billion people who earn more are causing all these problems. Look, if we talk about climate change, 51 plus 22, so 73% of the cost for crossing the boundary is attributed to the 20 top percent of people. And it goes like this for the other measures. So the wealthy people are the ones who are causing the problem. And in order to illustrate it in a more direct way, let's define this Americum. Americum is a unit of 350 million people that earn about $15,000 per year per capita, including kids and elderly people, with growing desire for consumerism. They want to spend the money, they want to travel around, they want to go to conferences. And
only 15,000 looks too small.
no, it's including your grandchildren.
Kids.
Okay, don't worry. Let's not talk about your salary. it doesn't matter. You can replace it with 40,000. The point is that the question is, how many Americans can the world sustain? In 1980s, we had about 2. Now we have 6 to 7. In 2030, maybe we'll have up to 9. And how many can the world sustain? It's clear that we cannot have 50 Americans, 100 Americans. So we're approaching the number of Americans. So, and it's, as I showed before, it's not only the sheer number of people, but it's the number of people who consume. And the good news, and this is some of the mitigation and processes that are taking place, is that we, as I already hinted before, that the rate of increase of human population is going down. Total fertility rate is the number of kids a woman gives birth to over a lifetime. It was about 5 back in 1950s, 70s, and now it is about 2.25 in 2023. And when it reached 2.1, within about 30 years later, number of people on Earth will stop growing. And there are various estimates. Some models predict it will happen in 2065. Some say that it will happen only in 2017 something, or even in 2100, but it will happen within a few decades. And I think it was yesterday or the day before yesterday when there was a report about China complaining that they cannot increase the numbers. I think this was the most positive news of the last month or so, that China is failing to increase the number of people, because in China, on top of the fact that it's such a huge country, also the standard of living is going up, which is good on a personal level, but it has a lot of consequences from the environmental side of it. So the other part, which is essentially needed, is to deal with GDP. We all worship GDP. And what's even worse than this is all the politicians worship. And in GDP, the way it is designed today, for instance, if you tear down or cut off a virgin tree forest, convert all the trees into furniture, sell them off, you increase the GDP. You created a huge negative impact on a vast piece of land, but it has only a positive side of it. So GDP has to be changed. And indeed, in 2025, there was a redefinition of the GDP, and they started introducing into GDP externalities. Meaning that if you want to improve the GDP of your country, you cannot harm the environment, because it will lower the GDP, the way it's being calculated. And there are others who go even further and propose alternatives to GDP, such as the prosperity index and others. This is just one example. So these things are happening, and these are maybe the most important ones. On top of it, we are seeing some advancements in dealing with the harm we cause to climate, and a lot of activities are being done with respect to CO2 sequestration. We know about CO2 sequestration in oceans by fertilizing them with trace metals, but with iron, for instance. But there are other sequestration attempts, either by mineralization in the mafic and ultramafic rocks, And of course, there's this Nobel Prize received by Omar Yagi and others for devising what they called the the covalent organic framework that basically can capture CO2 from open air and convert it to a mineral form. If this will be done in a large enough scale, it might be very useful and will solve some of the issue of excess CO2 in the atmosphere. Also, we see that when we compare the cost of producing energy, which goes throughout its life cycle, from the most efficient fossil fuel combined gas cycle, and compare it to wind and to certain types of photovoltaic cells, we see that the cost is similar. So even economically, it becomes efficient and beneficial to switch from fossil fuels to alternative sources of energy. And when we look at even at the fossil fuels or other sources of energy which are based on heat, we see that the huge fraction of the energy that we put into production is a waste to the environment. And there are a lot of attempts now to use this excess heat to convert it into energy and therefore substantially increase the efficiency of all thermal power plants, including fossil fuels, but also nuclear power plants. So, we also know that in order to improve further the efficiency of our energy system and economy, we have to create a network of energy that includes both producers, consumers, storage facilities, and connect different regions. For instance, create energy in solar energy in places which receive enough sunlight and transport it to other regions. A key player in this is hydrogen, and although people talk a lot about what they call green hydrogen produced by electrolysis of water by sunlight, there are some indications for geological reservoirs of hydrogen that can be extracted and used. On top of it, we have seen in the last few years major improvement in high-density sources, such as geothermal sources, nuclear fission, the breeders, the fourth generation, and maybe in the next 10 or 20 years, we will see the nuclear fusion reactors coming into play. So this combination of things might help us completely revolutionize the energy sector of the Earth. And on top of it, we have to move away from demand-based industrial agriculture such as this and move to either organic or what they call a regenerative agriculture, which has utilized practices that do not harm the environment, do not destroy the soil, and even enhance its ability to absorb and to accumulate carbon. And the transition to this is also is happening on a relatively wide scale in various countries, in various organizations, including, by the way, in Israel. Israel has the Ministry of Agriculture has a farm where they test all kinds of practices. It's called Neve Yaar in North Israel. 400 dunams out of the 1,200 dunams that they have there are dedicated to regenerative agriculture. So this is the future. And if this materializes, it will have a huge impact. And also it comes along with the use of precision agriculture, all kinds of devices to enhance our ability to irrigate smartly, to add not too much fertilizers, and so forth. And on a personal level, we have to eat lower on the food web, as I showed you before. Doesn't mean I do not, how do you call it, I don't try to convince you to become vegans. But if we just lower the consumption of meat and dairy products from daily to, let's say, weekly or bi-weekly, this will have a huge impact on the environment. So, to summarize, the issue of environmental problems, I think, has a pyramid type of structure. The basis of everything is the population growth and the increase in consumption, which leads to the consumption of energy, food, water, raw materials, which cause perturbation of biogeochemical cycles, which lead to all these problems that I showed you and many more that I haven't touched on. It's water shortage, sea level rise, and species extinction, and so forth, which lead to global changes such as global warming and others, and cause harm to humans and to the biosphere. And in order to solve all these issues that I showed you, we have to tackle them together. Deal with warming, wildlife, and pollution together. Because otherwise, we might create problems, unanticipated problems, while dealing with one of the aspects. And I will end with a quote from Yosef Agassi, who says that we must be optimists. Optimism, when taken as a factual assessment, is unreliable, but it is the moral duty. One must give God the benefit of the doubt. If one does not adopt an optimistic view of the world, it becomes very easy to use it as an excuse for inaction. Thank you.
Thank you. Questions? Oh, yeah.
So Israel is one of the countries with the highest fertility rate and also GDP. So are we the bad guys? Are all of the enemies correct? Are we the bad guys in this?
Well, Israel definitely has a severe environmental problems. We know it. One of the things that it's almost you cannot talk about it in the political arena is limit the growth of population in Israel. But yes, we have a TFR of more than 3 overall. And there are sectors which have much more than this. There are sectors which have lower. So yes, Israel is a problem. On a global scale, of course, Israel is only 1 per million. We are 1 per million of the population of the world. We consume about 1 per million or 2 per million of the energy. And so, yes, Israel is definitely not, environmentally speaking, on the right track.
So we should kill more.
You mentioned the historic review, Al Gore and all the hysteria that were in the 90s, like to your opinion about, are we delivering an optimistic view to policymakers, or are we more like Al Gore, let's say we have a real issue that, if not in economic, global, geopolitical essence, will move something, and if you only listen to a bit of what Trump's saying about anything regarding climate, there is no conversation even there, and there is the NOAA budget and so on, so on. So I would like to your opinion about what's our best, like, what do we say to the world as a scientist?
First of all, this is a dilemma because in order to draw the attention of politicians, we thought that we have to raise our voices. And the ones who raise more loudly than others draw more attention, and the others, how many of us are aware of the problems of plastics that happen everywhere? Or as I said, the PFAS, for instance, they basically increase the incidence of cancer, of liver cancer in certain parts of the world because of exposure. So the problem is very complicated because it touches on the very basic assumptions of our Western world, that we should consume, we should always aim to increase our standard of living, we want kids, many kids. So when you realize that you have to change this, it becomes very, very, very problematic. And what I'm saying is that I'm relatively optimistic about the issue of climate, in spite of Trump, because I think processes that are happening in the US even, and definitely outside the US, China, Europe, and the fact that technologically we are already in a stage where the cost of alternative energy sources is not more expensive than fossil fuels. We will solve the climate problem. But I'm afraid it will create other problems. And unless we lower our footprint on the environment.
But does politicians, first of all, aware of these more economical advantages you suggest? And do they even care?
I think you'd have to ask them.
The question is a moral question, because if we change our moral views about what is allowed, what is not allowed, it's not allowed to kill people even if it's economically beneficial. It's not allowed to have slaves even if it's economically beneficial. But it is allowed to pollute a river morally. It's considered moral. Still, you're not put in jail for that for a long time. You might pay a small fine. So until we change our moral ladder about what is right, what is wrong, and then punish people who are behaving immorally by huge fines like CO2 fines, nothing will change. This is at the bottom of everything. So we have skewed preferences right now, and until we do that, and that is a choice that we do, and how we educate our kids, and until we do that, then nothing will change.
We are in a collision course. We're in a collision course with the environment. Even the Secretary General of the UN said about it. Basically, humanity has engaged in a war against nature. This is what he said. We are in the wrong direction.
Yigal, I agree very much with you, with your optimism based on the economy, economics, but it is, the problem is that, and I think that we should put more emphasis on that, because it is economically, at a global perspective, more economical to do high efficiency, high-tech food growing, to go to electrical cars and so on. And it is a government regulations that prevent us to do that, and we have a colossal global market failure in moving to that direction. I believe it will be good if we divert our energy to allow the regulations to change. How much of that is
Yes.
happening?
We definitely have to, well, it depends where. Of course, in the US it's going the wrong direction, but in other places it's going in the right direction. And of course, Israel is a proxy of the US, so it goes along with the US. Just today there was in the newspaper that Israel is considering, how do you call it, withdrawing from Paris.
The new United Nations.
No, the Paris
Paris agreement.
agreement.
12 o'clock emergency Zoom right now on this topic.
Yes.
Question in back.
Is there any evaluation on the environmental impact of the wars of Israel, like recent ones, especially the Gaza and the Iran?
Yeah, there were some reports about the damage in Gaza. I don't know anything about Lebanon and Syria, but in Gaza, yes, both in Gaza itself and in the environment around Gaza, because of demolition, for instance, of buildings which had asbestos in them, or spraying of all kind of explosives and contaminating the aquifer with oil and gasoline and stuff like this, which was washed by rainwater. Yes, there is a report. If you want, I have it, so I can send it to you.
Right, well, I think we've run over time, so let's thank Yigal again. Thank you.